Please welcome with me the Institute Director at Fraunhofer Institute for Building Physics, IBP, Professor Dr. Philipp Leistner.
Thank you very much. Maybe it's, I don't know, it's a sign that you are sitting here for the construction industry to listen what we have to tell you about this industry. And for other industries, there are much more, maybe more activities and so on. By the way, the construction industry is not so different, not in all aspects different to other sectors in the industry in Germany and worldwide, but there are some peculiarities, as you know, I hope as you know, which has to be considered. And you see the title of my presentation, let's go back. The title of my presentation, Home Remedies. What is typical for home remedies? Maybe you can ask yourself, what are home remedies? For example, for circulatory disturbance. I think that home remedies are simple, but effective. Second point is they are hopefully without any side effects. And they are regionally available and highly accepted. And now the question is, what is the bridge to the real circular aspects of the construction industry? First point from my side is that the industry is very heterogeneous and the construction process is very complex. So when we talk about circular aspects, new circular aspects in the construction industry, we should at least at the beginning keep it simple, feasible, and of course also regional, because the construction process is very regional. When I talk about regionally aspects of construction, look at these figures at the left side. You see gravel and sand pits, and on the one hand, and on the other hand, the landfill sites. And if you now ask a municipality in Germany, what do you think about a new sand or gravel pit, or even a new landfill site? You will have how should I say, not so many people on your side, and most of the people will say no. This is not really what we would like to have in our municipality, in our city, or in our village, because it's not really beneficial for us. And when we have at the beginning, or at the start, and at the end of the value chain such a problem, such a societal problem, then we should take care what we are really doing. So we should think holistically. Of course, another point, apart from availability and acceptance, is sustainability. That's clear for all the sectors and for all circular loops. But also in the construction sector, we have to consider economic, environmental, and social aspects. The availability in the construction sector, some people say this is not so important. We do not need these special things from China or anywhere else, but some of the materials are also needed and difficult to get. We have another special point for construction industry. We have not a really high productivity. Actually, it's quite low. Of course, we also need a profitability. This is also needed for the construction sector. And we have partly at least, a long life cycle. Of course, especially the use phase of the building should be as long as possible, 50 years, 100 years. This is good. This is in the sense of sustainability and also of circularity. But this is also important for developing new technologies. Bring new technology in the market. You need a certain time, and you have long amortization times, and also, of course, high investment. These are some typical aspects from my point of view in the construction industry, also with an effect on the circular technologies. What could be the goal? Accountable goal, which can be counted in terms of greenhouse gases, in terms of money, in terms of other aspects, and so on. Here you can see from the United Nations Environment Programme a goal. This is one idea of a goal, and you can see from the left side, 4 years ago, 2020, the next 3 or 4 decades, what is the idea of the United Nations, where we should go with the construction materials in the future. Please consider that there are some areas, you see here the primary materials, and the hatched areas are the secondary materials. And now look, for example, at the concrete On the right hand of the diagram, you see that only a few amount of new concrete is planned in this figure, and a big amount of secondary concrete. That means in a circular way. And this is also for the bio-based materials. So if you look now at the situation now, the state of the art, then we see a big and challenging goal. Maybe there are some other perspectives. This is only one idea, but the perspectives are similar in a certain way, and we should keep them in mind. There are a lot of numbers. I don't have so many numbers in my presentation, but if you listen that we have in the construction, with regard to construction material, deconstruction material, a recycling rate of 90%, actually it sounds good. Everybody would be proud. 90%, really good. But the most of these 90%, or almost all of these 90%, are in a way that we have actually valuable raw materials transferred to, how should I say, to a use with a low value. That means the value of the materials is going down. So we have a lot of recycling, but it is not on the level we really need. Why? And why? My answer on the question why are in three examples. You see here some points. The heterogeneous material is very difficult to handle. It prevents high quality use. Then we have the quality itself, with a picture here of concrete additives or concrete gravel. Yeah? Once here is by mechanical crushing. It's not on the quality state that you can see for recycling concrete. I can use this without any problem again. And we have a lot of, in the building sector, this is also very special, a lot of contaminants, pollutants, toxic materials in the buildings. I will give you a few examples how we can deal with this, with new technologies, with new approaches. I'm coming from the Research Institute, basic and applied research, and we are trying to suggest some technologies which are good and supporting this circularity in the construction industry. First example are these insulation materials, especially the external, for facades, external thermal insulation. These are composite systems, a lot of materials combined and glued to each other. You see here plaster, fabric, mortar, dowels and foam and so on. Of course, this is actually a nightmare for recycling, to bring this material, to separate these materials, but we have to do this. We need selection processes, whether really selective or partly selective, or maybe there are other approaches. We have to do this, and when we did it, then of course we need new approaches to deal with these separated materials. For example, with polystyrene, this is foam material for insulation, very cheap, actually not so bad, also in physical properties. And we have in these materials a lot of flame retardants. For example, you can see here, this is bromine, not really good, but one can, there's a second life for these materials. And this, for example, is an idea, is an approach, and we did it with a certain technology, so-called creosote from another Fraunhofer Institute and from building physics. And the idea behind, you can see this here in the lower part, even today, we bring new components in the material in the buildings, which has contaminants inside. Some people can't believe this. We still today, tomorrow, we bring materials in the buildings which are not free of contaminants. I guess we should stop this first, and on the other hand, we should try to find these materials, bring them out of the existing buildings and consider them as raw materials for next upcycling and other applications. Second example, it's really nice for all engineers, they love it, how to separate these materials. Here for mineral materials, concrete, gypsum, sand lime brick, clay brick, whatever. This is, make it smaller and smaller, and then the next challenge is sorting. You have a lot of different materials in one amount of these granulars that you have to separate to each other by sorting materials, and you have some optical technologies today which are very, very performing. You can use for different materials, you can separate really clear and sorting really clear. And this is a nice, from my point of view, a nice technology which is now on the step to be scaled it up. That means that it is fast enough to handle a lot of material in a short time. So the performance should be increased, and this is on the way now. I like this, therefore. Another also, in terms of quality, you remember the picture of the crushed concrete, to avoid these less quality, or to increase the quality of the crushed material, to use it better in the next step, is this electrodynamic fragmentation technology. Somebody heard about this. This is with a high amount of charge, of electrical charge. You have a plasma channel when the charge is going through the material to the mix of material. And due to this high charge and plasma channel, you have a explosion, a blast wave, a pressure wave, a high pressure wave. And at the result, you have these separated materials. Now it's, of course, for the show, for the gallery. It's made in different, on different places. But we really can separate these materials, also concrete, in this quality. And on the right-hand side, you see the comparison of electrodynamically fragmented materials or mechanically crushed materials. We can see a difference, but believe me, this difference is good. The electrodynamic fragmentation is leading to materials, to separated materials, which can really good use in high quality for the next life of this stuff. And the third example, from concrete to wood, brick, masonry, concrete, wood, is this one. Actually, we followed this technology, or we created this technology for the improved use of buildings, and there are a lot of buildings in Germany at least, with preservatives, with wood preservatives. You see here these dangerous words like lindan or PCP. You can see also the Latin description of these words. We have 3 million buildings in Germany with these actually toxic materials in the wood. Since the 70s or 80s we had these. We used this in Germany. And now the question is how we can bring these toxic or contaminants out of this wood. Either to improve the quality of the buildings when the wood is still part of the building, or to use this wood also for a second life. Secondary wood, bring this into new components for the buildings. And the technology which we used here was, I think, quite a tricky one. This is a combination of an encapsulation of these substances in the wood by these materials you can see here. And the second step is to inactivate this material. It's this inactivation using a plasma. It sounds very difficult. We learned it from the COVID, from technologies to deal with the COVID virus in the air, in the buildings, how we can inactivate them. And now we use this technology to inactivate other organic but toxic materials to deal with this. The final slide is, it's a very short presentation, it's almost too short, and the acoustics is also very special. Better communication, you can use this immediately after the session here at the booth A12, together with other Fraunhofer institutes which are collected in the especially Alliance. You see here the number, and tomorrow we are in the master classes. Thank you very much for your attention.